Okay, let's do this. Again, I'll post the notes in the chat. If you need to download them, there they are again. And today we are going over marginal analysis. And marginal is just a fancy word for derivative, because now we're going to be dealing with the cost, revenue, and profit functions. And if you ever see marginal cost, marginal revenue, marginal profit, all that's saying is take the derivative of that given function. So if you see in the blue, cost function C of x, marginal cost would be the derivative of the cost function C prime of x. And then we have average cost, C bar of x. That is given as C of x over x. You've guys seen that one before from 1324. And we can also take the derivative of average cost being C bar prime of x. Okay, so these are just all the notations and definitions of what we're dealing with today. The same can be said for revenue, R prime of x, R bar of x, and R bar prime of x. And same with profit. We know profit is made by doing the revenue minus the cost function. The derivative of profit is P prime, which also can be given by the derivative of revenue minus the derivative of cost. And then there's also average profit, P bar of x, and P bar prime of x, the derivative. Okay, so we are dealing with marginal revenue, and we're going to deal with average revenue or average cost, profit, revenue, all the functions today. So our first theorem is marginal cost and exact cost. So the first thing here is something called the exact cost formula. This formula finds the exact cost of one item. So the formula we use is C of x plus 1 minus C of x. This will give us the exact cost of exactly one item. Okay. And then, all right. And then marginal cost. So the marginal cost, the derivative of the cost function, will approximate the exact cost of producing the x plus first item. And that formula is given as C prime of x will be approximately equal to the exact cost of one item. So you can use this formula for revenue and profit functions as well. So we are going to try out below the exact cost and marginal cost and compare the two. Okay. So for example 1, it says a company manufactures fuel tanks for cars. The total weekly cost in dollars of producing X tanks is given by C of X equals 10,000 plus 90X minus 0.05X squared. A, find the exact cost of producing the 501st fuel tank. Okay, so we're going to use the exact cost formula for this problem for A. So for A, we want the exact cost. And the way to find exact cost is we're going to take 501. So we're going to say C of 501 and subtract C of 500. So whenever you're doing the exact cost formula, a good rule of thumb is if you want to know the exact cost of the 501st, you're always going to subtract one below 500. So if it was find the exact cost of the 502nd, it would be 502 minus 501. So you always do one less. All right. And now what we're going to do is take these values and plug them into the cost function for X. So let's see what we get. I'm going to go to Desmos, my favorite, and boom, play with this function. So I'm going to type in this function, 10,000 plus 90x minus 0.05x squared. Make sure I have everything in there correctly. And then I'm just going to make it into a table. And now I'll get to choose these values. There we go. So I'm going to type in 501 and I'm going to type in 500. And bam, look at that. Gives me those values already. So over here, I'll just write those down. Oops, don't want that. So we're going to get $42,539.95 minus 42,500. Okay. And now if you subtract those two terms, you're going to end up with the exact cost of the 501st fuel tank being $39.95. So that's the exact cost of the 501st fuel tank. Okay. So that is how you calculate exact cost. And now for B, we want to use the marginal cost to approximate the cost of producing the 501st fuel tank. So for B, we're going to take the derivative of the cost function and plug in 501. So for B, we're going to say C prime of X. And if we remember our shortcut derivative rules from Monday, what is the derivative of 10,000?
0.
0. Good. What is the derivative of 90x?
1.
Well, the derivative of x is 1, which means we would be left with
90.
There you go.
Negative
90 minus, and now what is the derivative of negative 0.05x squared? Remember that 2 comes down, multiplies the 0.05. So what's 2 times 5 cents?
0.10.
There you go. There's our derivative. And now all we have to do is plug in 501. So C prime of 501 equal to 90 minus 0.10 times 501. And let's see what we get. We should get something really close to the answer we got in A. And here we get $39.90. So, just like the theorem says, the marginal cost will be approximately equal to the exact cost.
So what's the purpose of a marginal cost?
So remember that all of this is about the derivative, right? So exact cost is saying, hey, this 501st fuel tank is $39.95. But what marginal cost is saying is, well, since it's a derivative, we have to think in terms of slope. So what we're saying is that at the 501st fuel tank, is our answer for the derivative positive or negative?
Positive.
Positive. So at the 501st fuel tank, our cost is what? Increasing or decreasing?
Decreasing.
If it's positive, it must be
Increasing.
increasing. So that's why we need a marginal cost or a marginal revenue or a marginal profit. Because remember what the derivative tells us is that the derivative says at exactly one single x value, at exactly 1 point, you can find the slope. So if this is marginal cost, we're saying that at the 501st fuel tank, cost is increasing by $39.90.
Quick question is that why if you buy things in bulk, is that why it's a bit cheaper is because of marginal cost?
I would assume so. But maybe that's more of an inventory thing, right?
Okay.
So I would assume like if you buy in bulk, maybe a store just wants to get it off its shelf and they're like, we'll give them at a discounted rate, you know?
Okay.
So, okay.
I got a quick question about
Go ahead.
can you confirm how you plugged in the X values for the exact cost formula?
Yes. So once again, 501 goes in for every X into the cost function. So you plug in 501 and you get 42,539. And then you'd plug in 500 for every X into the cost function and you'd get 42,500.
Got it. Thank you.
Yep. All right. Any other questions before moving on? So just try to understand that marginal means derivative. So you have to think in terms of slope. So if you get a positive answer, your slope is increasing. And it could be in terms of cost, revenue, or profit. So if you have a positive output, you're increasing, you're increasing, you're increasing. If you have a negative output, then you would be decreasing. All right. All right. Good questions. Okay. And now, example 2. The total cost of producing X bicycles is given by the function C of X equals 10,000 plus 150X. Find the average cost per unit if 125 bicycles are produced. So now we want to find the average cost. So this brings us back to our good old 1324, your last semester. So remember that average cost, and the formula is on the first page. Average cost is given by C bar of X equal to the cost function over X. Now, all we're going to do to find the average cost function is take this cost function and put it over X. And after we do that, we're going to plug in 125. So we're going to say C bar of X is equal to 10,000 plus 150X all over X. There's your average cost function. Now plug in 125. And I'll just use my calculator here. And 10,000 plus 150 times 125 over 125 says that if we make 125 bicycles, our average cost will be $230. Okay. Any questions on that? Okay. So with B says find the marginal average cost at a production level of 125 units. So now we're looking for the marginal average cost, which means we need to take the derivative of the average cost function. So let's go ahead and rewrite our average cost function. So I'll rewrite it down here. Average cost, the same one from above, which is C bar of X equal to 10,000 plus 150X over X. And now our job is to take the derivative of this function. But we can't take the derivative in this form. So if you remember last class, we were able to split a fraction up. So again, how could I rewrite this so we can take the derivative? How could I split it up?
Over x, and then 150x over x.
Good. 10,000 over x, and then 150x over x. Okay, but now we still have a little more cleaning up to do. And what's another way to rewrite 10,000 over x? (10,000x to the what power?
-1.
That's it.
-1.
Yep, -1. And then on your 150x over x, your x's are going to
Cancel.
cancel. So you're just left with 150. Now we have put the average cost function into a form that we can take the derivative of now. So now let's go ahead and find the marginal average cost. The MAC, why not? Marginal average cost. And this is going to be given by C bar prime of x. And now, what is the derivative of 10,000x to the -1? What was that?
Negative 10,000 x to the -2 power.
That's it. Negative 10,000x to the -2. And what's the derivative of 150?
0.
That's it. So there's your marginal average cost function. Now all we have to do is plug in 125. And negative 10,000 times 125 raised to the -2 will give me -64 cents. So this says to interpret the results. So remember to always think of slope. Did we get a positive or negative output?
Negative.
A negative output. This means that at 125 bikes, our cost is increasing, our average cost is increasing or decreasing?
Decreasing.
Decreasing, because it's negative, right?
Sir.
So if we're producing 125 bikes, and if we go past that, our average cost of producing these bikes is going to decrease. Now, what could be a factor in the cost decreasing? Well, one of the factors could be the price we actually sell these bikes at. So if your bike cost, if you're selling the bike at a higher price than it takes to make the bikes, then yes, eventually your cost will decrease because now you're making more money than it costs to produce them.
Business.
All right. Any questions on those two so far? Because the next question is going to use the answers from A and B. The next question says, use the results from A and B to estimate the average cost per bicycle if 126 bicycles are produced. So what do you think we do here? Because if you look at answer A, how much does it cost to produce 125 bikes?
230.
230, right? It cost us $230 to produce 125 bikes. And then what answer B says, it says if we could keep producing after 125 units, the cost is going to decrease by how much?
64 cents.
64 cents. So this means if we make 126 bicycles, what's going to be the cost of those?
$229.
That's it. Because you
Okay.
would add the negative 64 cents, because remember, if we keep producing bikes, the cost is going to keep going down. So this means you take your 230, you add it to your negative 64 cents, and the cost of the 126 bicycle will be $229 and what, 36 cents?
No.
And that's it. This is the average cost of 126 bicycles. Oh yeah, okay, cool. So, any questions on that page? Okay, cool. So that's average cost and marginal average cost. All right, last page, the long one. A company's market research department recommends the manufacture and marketing of a new headphone set for Apple and Android phones. After suitable test marketing, the research department presents the following price demand equation. X equals 10,000 minus 1,000 P, where X is the number of headphones that retailers are likely to buy at price P per set. The financial department gives the cost function, C of X equals 7,000 plus 2X, where 7,000 is fixed cost and $2 is the estimate of variable cost per headphone. Okay. So in the price demand equation given above, express the price P as a function of the demand X and find its domain of this function. So what this wants us to do is take the price demand equation given, solve it for P, and then find the domain of the actual function. So let's go ahead and do that first. If we find the domain of our function, then we will know what restrictions we must, we will know the restrictions to stay between that will make this company successful. So let's go ahead and do that. Got room over here. Okay, so for A, I'm going to rewrite the price demand equation. X equals 10,000 minus 1,000 P. And we're going to solve this equation for P. So the first thing to move over is that 10,000. So we're going to have X minus 10,000 equal to negative 1,000 P. And then you're going to divide everything by negative 1,000. And this is going to give me negative x over 1,000 plus 10 equal to p. And all I'm going to do is rewrite this as a decimal number, such as 1 over 1,000, which is negative 0.001 x plus 10 equal to p. And now we have our price in terms of x. Earlier up here, it was x in terms of price, but now we have price in terms of x, which means we are going to be able to find the domain, because now what we're going to do is take our new price equation. So let me just split this off. And let's think about domain for a bit. If we're talking about price, price can never go below what number?
Zero.
0. Good. So our price equation can never go below 0. We would hope not, right? This is a business model. If price goes below 0, we're giving free stuff away. So what we're going to do is take our price equation and set it greater than or equal to 0. And now we're going to plug in the price equation that we just found, negative 0.001x plus 10, set it greater than or equal to 0, and solve this for x. So you'll move the 10 over, and you get negative 0.001x greater than or equal to negative 10. And then you'll divide by negative 0.001, and we'll get x. And what happens to the inequality when you divide or multiply by a negative?
It flips.
It flips. So you get x is less than or equal to 10,000. Okay. So now, to piece this domain together, we need to piece this first piece and this second piece together. So in order to be a profitable company, the number of headphones we must sell must be above what number? We must be above 0, but we can't go more than how many?
10,000.
10,000. There you go. There's our domain for this problem. This is going to be the domain for all the functions we are going to come up with in the next couple of steps.
Sir, can I see the first part of this problem?
Right there.
Yeah.
Okay. And again, the reason we did this is because we want to know where should we exist in order to be a profitable company. And what this domain is telling us is that in order to be profitable, we have to make between 0 and 10,000 headphones to be successful. So somewhere in between those two numbers, we're going to make a lot of money. But we're not going to make a lot of money at 0 and 10,000. So somewhere in between there. All right. So B. B says, find the marginal cost function This one is simple because they give us the cost function, and all we have to do is take the derivative of it. So what is the derivative of this cost function? What's the derivative of 7,000?
0? Isn't it just
0.
like 2?
Good. And what's the derivative of 2x?
2.
That's it. There's your marginal cost function. And like I said, whenever you see marginal, you think derivative. And whenever you think derivative, you think of slope. Look at your cost function. What is the slope of this function?
2.
2. So that would be right for the derivative to tell us that the slope is 2. That's what it does. And what this marginal cost function is telling you that is that every time we make a headphone, we're getting charged how much per headphone?
2.
$2.
$2.
Good. Okay. Any questions so far?
Okay.
All right. Now C says find the revenue function and state its domain. Now remember to find revenue. This is from 1324. Revenue is X, the amount of items, times the price P that we sell them at. So our job here is to create a revenue function. And we have all the pieces already. So revenue is given times X times P. X is the number of headphones. And did we create an equation for P in step A?
Yes.
Yes.
Right here. So you're going to plug all of that in for P. Negative 0.001x plus 10. There it is. And now distribute the X and we have our revenue function. Negative 0.001x squared plus 10x. There is revenue. And then it said state this function's domain. Well, our revenue, our cost, and our profit function are all going to have to abide by the same domain of 0 to 10,000. So here, our domain is still 0 less than or equal to x less than or equal to 10,000. Okay, there's revenue. Now D says find the marginal revenue function and plug in 2,000, 5,000, and 7,000. So for D, we're going to take the revenue function we just found and take the derivative of it. So R prime of X, and what's the derivative of negative 0.001x squared?
Was 0?
So remember that 2 comes down
Wait,
and multiplies the 001, giving me 002x
2.
plus, what's the derivative of 10x?
1.
10.
10.
10.
Good. The derivative of x is 1, which means 10 times 1 would be 10. So there's our marginal revenue function. And now we're going to plug in 2,000, 5,000, and 7,000 into this marginal revenue and interpret the results. So I'll have R prime of 2,000, R prime of 5,000, and our prime of 7,000. And I'll go Desmos, sure, since I have it up. All right, I don't need that anymore. I'll type in this function, negative 0.002x plus 10. Make it into a table. And type in 2,000, 5,000, and 7,000. Okay. And here's what I get. 6, 0, -4. Okay. Now I'll come back to the notes. And now this says to interpret the result. Well, like I said, think about slope. So if we make 2,000 headphones, this means we're making how much in revenue per headphone?
$6.
6, right? $6 per headphone. This means our revenue is what? Increasing or decreasing?
Increasing.
Revenue increase. And now at 5,000 headphones, we have 0. So what does this mean? What's our revenue doing? It's kind of like we've increased and now we're kind of flat. We're plateauing. So what would you call that?
Break even?
Close to breaking even, right? So what we're going to say is that, so the slope is $0. So like I said, we plateaued. We're still making headphones and we're still making money, but we're not making any more money, which means our revenue is going to remain constant. And then when we make 7,000 headphones, what's happening to our revenue?
Decreases.
Revenue decreases. There you go. So 2,000, and everything could be a factor here, right? We just spread out these headphones. They're new, they're popular, everybody wants them. So 2,000 headphones, great. People love them. They're buying them full price. So we're getting $6 per set of headphones. And then 5,000 headphones, like, okay, we're still new, but now maybe we've given a little discount. So now we're still making money, but not as much. But then now we make 7,000 headphones, and now our headphones are probably not that hot on the market anymore. Maybe there was a bunch of defects. Who knows? Which means we have too many out, nobody's buying them, or they are buying them, but at a really discounted rate. So now revenue is decreasing by $4 per headset. And again, just like to give visual on what you're looking at. So our revenue function is given by x squared. X squared is the graph of a parabola. And negative x squared means our parabola opens down. So what we have found is the slope at exactly these x values. So the first one was at 2,000 headsets, and we found that the revenue was increasing by $6. That's the slope at that point. And then next we saw that at 5,000 headsets, we had a slope of 0. So like I said, we're plateauing out. We're making money still, but not as much. And now, when we have too many items out, at 7,000 headsets, our slope is decreasing. And that's all you're finding is the slope of that function. How well is our revenue actually doing? Okay. Any questions so far?
So at what point is the company best off, at 5,000 or 2,000?
I'd say in between 2,000 and 5,000.
Okay.
Then anything after 5,000 is a loss.
Depends on demand, I guess.
Yep.
So 5,000 wouldn't be a max profit.
For this function, it most likely would, because 5,000 could be considered your vertex, but it wouldn't be max profit. It would be max revenue.
Okay.
Because remember, to get profit, you'd have to do revenue minus cost. So that'd be something different.
Okay.
But for now, yes, 5,000 would most likely be the max revenue, the most amount of money we can make before we start losing money. Okay. E, graph the cost function, revenue function on the same coordinate system. Find the break-even points and indicate regions of loss and profit. Okay. So we want to graph this function, and our domain for this function has been the same from 0 to 10,000. So I'm going to go ahead and label the x-axis from 0 to 10,000, and I'll probably just do it by tens. All right. So let me go ahead and do that. So here's going to be, oops. Here's going to be 0, and I think I can just go by tens, right? We can say, or I can just go by, if I did that, 1, yeah, I'll just go by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But remember that these are in the thousands. And for my y values, well, we'll find that out in a second. Because if you guys remember from 1324 and from your review day, one of the only ways to find break-even points was to use the quadratic formula, right? Which that can take a very long time. So I'm going to show you guys how to use a nice little shortcut on Desmos. It's going to be great. And I think because my MATLAB is just going to say, choose this graph. It's not going to make you graph it. So watch this. I'm going to type in the cost function, which is right there. 7,000 plus 2x. And then I'm going to type in the revenue function, which is in our green box there. Negative 0.001 x squared plus 10x. Okay, but in order for you to see this on Desmos, you're going to have to make some restriction changes. So there's a little wrench icon in the top right corner. So if you click on that, it's going to have the restrictions for the x-axis and y-axis. So for my x-axis, I'm going to put in what our domain is, 0 to 10,000. And then for my y values, I'm going to start at 0. And for this one, I had to play around, and I went ahead and chose 25,000. If you really want to know how to get that value, you're going to have to find the vertex of the revenue function. But again, I'm just saving you some time here. 0 to 25,000. Once you put your restrictions in, look what we have. We have a nicely graphed revenue and cost function. So now looking at my y values, I can come back to this sketch of a graph we have. And since it goes up to 25,000, I'm just going to say go by fives. This will be 5, 10, 15, 20, 25. And now I'm going to sketch this graph based on what I just did on Desmos. So my revenue function is going to look something like this. Doesn't have to be perfect, just comes down. There we go. And then my cost function is going to look like this. It starts at 7,000 and it's going to cross right there. Oh, I don't have to go further. We stop at actually 10,000. So something like that. Okay. So all it wants to do for this sketch is find where the regions of profit are and where profit loss is. So if you remember from these graphs, everything between the revenue and cost function right here is considered profit. So all of this in that lovely hump is considered profit. Everything outside of it, down here and down here, actually she used a different color. Everything down here and down here would be considered a what?
Loss.
A loss. Good. So here and here are considered a loss. And then the next part of this problem said to find the break-even points. Well, right here where we intersect are the break-even points. And what's beautiful about Desmos is all you have to do is click on the graphs and it'll give you the exact intersection points, which are your break-even points. It's too easy, and that's it, right? So all I'm going to say is my break-even points are at 1,000 and 9,000 and 7,000 and 21,000. Those are my break-even points. So I've just showed you this method. This is a method you can use on your homework and test, and it'll save a lot of time. Because if we tried the quadratic formula, we'd be still doing it for another 20 minutes. And I don't think you guys want to do that, huh?
No, sir.
Now, if you really wanted to go that way, well, we'll probably have time after class if you really want to see the quadratic formula. But other than that, Desmos is your best friend.
How did you figure out the limits of the graph?
So the first limits of the graph were given by the domain. So we were given the domain in the beginning, right? 0 to 10,000.
Mm-hmm.
So I plugged that in. But to find out your y values, the easiest way to find the y values, you're going to have to find the, where is it? So for the revenue function, you're going to have to find the vertex.
And that'd just be b over.
Yeah, so it'd be, so remember for your vertex, x would be negative b over 2a, and y would be f of negative b over 2a. And this is what you're actually looking for, is that y value. And that y value should give you somewhere around 25,000. All right. All right. So there's that. Making the work easy. And now on to F. Find the profit function in terms of X. Okay, so now our job is to find profit. Let me move this up. Let's see. Oops. Right here, you're gonna go right there. Okay. Okay. So now on the profit, remember that profit is given by revenue minus cost. So what we're going to do is take the revenue function we found above, which is in green, negative 0.001x squared plus 10x, and plug that in. So negative 0.001x squared plus 10x. And then we're going to subtract the cost function that was given above, and I believe it's 7,000 plus 2x, distribute that negative, and clean it up. And our profit function was going to be negative 0.001x squared plus 8x minus 7,000. There's profit. Okay. And now, the very last question. Find the marginal profit. So take the derivative of the profit function and plug in 1,000, 4,000, and 6,000 and interpret the results. So looking at this, we're going to have P prime of X. And again, what is the derivative of negative 0.001x squared?
Negative 2,000ths over x or x.
Well, yeah, I mean, it'd be what, 2 over 1,000 or negative 0.02x, right? Plus, what's the derivative of 8x?
8.
8. And what's the derivative of 7,000?
0.
0.
0. So there it is. There's your marginal profit. And now just plug in all these values. P prime of 1,000. P prime of 4,000. And P prime of 6,000. And if I plug that in, what can I do? Go back to minimize. Here, you, back to that. Go here. And I'll type this in. Negative 0.002x plus 8. Make it a table. And then over here, I'll type in 1,000, 4,000, 6,000. Hey, look at that. Same numbers from above. 6, 0, negative 4. And again, just interpret. So what we're saying is that at 1,000 headsets, our profit is increasing by $6. So profit increase. And then at 4,000 headsets, profit is going to remain what?
Constant.
Constant. And at 6,000 headsets, profit will
Decrease.
decrease. And there you go. That's it. I forgot to erase that. Bam. There we go. And that is marginal analysis, guys. Yeehaw.